Hello, welcome to Introduction to Java Programming. In this session, we will learn about control statements in Java. Let's begin. So as part of the basic programming constructs, so we have seen what is char set, then what are identifiers, and then operators. So by knowing this thing, we can actually write programs just like this. So now I can declare variables, I can put some statements, and I can have certain expressions by using the operators, and we can have a Java program ready and it's running. But how do you make decisions? How do you control your program? That means based on certain condition, I want to execute some parts of the program and I want to skip some parts of the program. And I want to make some of the statements getting executed repeatedly. Now, maybe after some point in the program, I want to jump and I have to come out. And suddenly I need to break my program and go out of some block or something. So that means there are good number of control statements available in programming languages. What are they? Let's see here actually. The control statements are divided into selection statements, looping statements, and jump statements. And there are two selection statements. One is if and another is switch. And we have three loops in almost all the programming languages: while, do while, and for. And there are jump statements like break, continue, and return. Let's understand one by one briefly. Let's come to if. If is a two-way statement. Two-way statement in the sense it will have two blocks. One is the true block, another is the false block. As an example, we can actually do like this. So let's assume you have two numbers. You have two numbers. Let's say int a equal to 10, comma b equal to some 20. Now, how do I write my two-way statement? If of the expression, and then here it has a block. This is called the true block. And it also has another block, that is the else block, that is a false block. Okay, so if takes an expression, if this expression is true, the contents in the true block are going to get executed and this else part will never get executed. If the expression is false, only the else part is going to get executed and true block will never get executed. So by doing this, we are actually controlling our program. I want some parts of the program to be executed and some parts of the program not to be executed. So that's the use of the control statements. And here, if can be of four forms. One is simple if. That means you are using only if, no else actually. So you say if of some expression, then you write your code. That means if it is true, write something. If of expression, if it is true, let's execute something, and you are not bothered about else. Okay, so for example, if a greater than b and a greater than c, then print a is biggest of the three. I don't bother about my else part. That is what simple if. So without else, that's a simple if. Then you can actually have if else. If else means both the statements actually. So true block statements as well as else block statement you can actually use. If a greater than 0, if a greater than or equal to 0, it's a positive number, else negative number. So I need not to write again another condition. Let me actually show you here. Okay, so how I'm doing is if some a value is there, right? So if a greater than 0 or equal to 0, then I can say here it is a positive number. In my true block, I will write it's a positive. Else here I'm going to write it's a negative number. So again here I need not to check for the condition. If a greater than or equal to 0 is false, definitely it is less than 0. And any number which is less than 0 is a negative number. So you will have two blocks. right? So if else will have two blocks actually. So out of which only one block is going to get executed. And nested if else. So you can actually nest. You can actually nest your if else things. As an example, here now what I'm saying, if a greater than 0, this is positive. A less than 0, here I can check actually. Else, the else part itself, I am actually checking for if. Else if a less than 0, then I say it's negative. And for this particular if, right, so there is another else part, and here in this else I will say it's actually 0. A greater than 0, it's a positive value. Else if a less than 0, that's a negative value. It's not greater, it's not lesser, then definitely that value is going to be 0, right? So now here what I did, if else, in the else I have another if actually. Okay, and in the if you can actually have one more if also, like this, one more if also. That means we can actually nest an if in another if, an if in an else part. Okay, so then we can actually call that as nested if else. Okay, so nesting of if else statements. Okay, then we have something called else if ladder, which is interesting. So here we are going to construct a ladder with the help of else if. So whenever you have more than 2-3 conditions to check, if is actually ideally shoots for two-way statements. That means we have only two things, two alternatives. Then we have to go for if. That's how if was introduced. But by nesting, we can actually check more than two conditions also. Okay. And if we have more conditions, then you can actually go for else if ladder and check for more. How you are going to do that actually is, so we will be writing a series of else ifs actually. So I say some if f expression, and then here if the expression is something, I write if it is true something. If it is false, then I will actually check for one more condition, else, and followed by again the expression. And if it is true, this is going to get executed, else, and I'm again checking the other condition. Okay, again, so here this true part, and if it's not true, then again I will check for the other condition. So like this, you can actually check for many conditions. So I am using else if, else if, else if, and here also I can use one more else if. Okay, like that, there is no limit. We can actually do as per the requirement. And finally, because if is there, right? So it is true, it is going to get executed. If it's a false, then I can actually write my else. If all my conditions are done, I can just write my else over here, and this is the else part, and my program is closed. So here I have 4 else if statements, and total how many conditions? 1, and these 4 plus 1 else part actually. So we are dealing with the 6 conditions. Okay, 6 conditions. If it is true, this one, else this one, else this one, else this one, else this one, or else this one actually. So ideally, if shoots for 2, but by nesting, we can actually process multiple conditions also by constructing else if ladder kind of thing. So if you write a program to do it, it will be more better, and I have more programs coming up, and we'll deal all these things one after other actually. Okay, so this is about the syntax of this else if ladder. Why I'm saying ladder? So we are constructing kind of ladder kind of thing actually. See here, 1, 2, 3, 4, a ladder kind of thing we are constructing. That's why these are called else if ladder. So this is about the if statement, and of course we are going to see with programs. And let's understand switch actually. So switch is a multi-way statement. We can say multi-way. It's not just a two-way. It's not just two-way, it's a multi-way. So two-way means you have only true part and else part, right? So multi-way means you have so many. So that's why switch expression always, whenever you take the switch expression always evaluates to not Boolean. Switch will evaluates not to Boolean actually. It evaluates to certain integral value. It can evaluate to certain string actually. It's not a Boolean value. The switch expression, it's not Boolean because Boolean means you have only two options, right? True and false. So it is actually integral, evaluates to integrals and a string actually. So integrals means what are integrals? So there are a number of integrals, right? So all integer types like byte, short, int, long is not allowed. Only three integers are allowed, and char also can be allowed actually. So all ints except long and char are called integrals, and string is also allowed as a expression. Okay. So because it has to take care of the multiple alternatives, right? So Boolean cannot suffice that requirement. So it can be integer. So I can actually have options 1 to 100. So switch off, I have 100 options and I can choose whatever you want actually, right? So you can choose among many alternatives in switch. And the switch, interestingly, has 4 keywords. Switch itself is a keyword. And here all the alternatives are cases. And then each case can be broken after it is fulfilled. And if none of the cases are matching, you have something called default actually. So if you see here the syntax, so switch off some expression, this expression is evaluating to certain integral, and here you can actually write a cases actually, case followed by label. So case 1. So what is about case 1? So you can write your code over here, and you can actually make, once your code is done for the case, you can actually break this. Otherwise, the code falls to for the next case also. Okay, if you see one example, you will definitely understand. So just I am giving that syntactical things. So case 1, case 2, and if you don't want to break this also, you can omit this break based on the requirement. And if none of the cases are matching, so we'll have a default. Let me write case n here. And finally, if none of the cases are matching, then we have to have this default one. Default is also keyword. Okay, so usually after you write a case, you have to break it. You have to break it. So whether to break or not, that depends upon your requirement actually. So default, usually we will write instruction or a warning statement. Okay, so this is the syntax. See here, switch, case, break, and default. There are 4 keywords. There are 4 keywords over here, right? So that is about switch, and we are going to see programs by taking string as an expression value or some integrals, etc. and etc. And one important fact is that we can always replace else if ladder with a switch. So else if ladder, we are actually making we are taking care of multiple alternatives that can directly be uh, eliminated. The need of else if ladder can be eliminated with the help of switch actually. Okay, in fact, if you see in Python, so we have only else if ladder possible, but there is no switch because these two are doing the same thing. Yeah. So then coming to the other statements, those are looping statements. So selection statements are some decision making. Some parts are executing and some parts are not getting executed. Whereas the looping statements, while, do while, for, and we have a variant for each, which help us to execute some parts of the program repeatedly, sometimes infinitely. So your block of the code will execute infinitely or particular time actually. So let me actually tell you. So one a simple use case of it. So I can actually say something like this. So while of, I am saying true, and here whatever you write, this is the body of the loop, and this body of the loop is going to get executed for infinite times, because there is no way to break this, because I am saying while true, always it is true, When it is true, your body of the loop is going to get executed. Only when it is false, it will come out here. But we are saying it is always true. So this is an infinite loop. The same thing we can write actually with for loop, and we can write with do while as well. But usually we will not make every time our things are infinite, unless and otherwise it is needed. So we will do something like this: while I less than or equal to 10. So what is I? So my I value I am going to initialize here. So int I equal to 1. And while I less than or equal to 10, as long as my I value is less than 10, my body of the loop is going to get executed. Whenever it becomes greater than 10, it comes out actually. So that's why you require some update statement inside, because I have to deal with my I value. So every time what I'm doing, I'm incrementing my I value. So sometime this I value will be greater than 10 and you will come out. Okay, so when I greater than 10, you will come out of that particular while loop. The same is the case with the do while and for loop as well actually. Okay, so this is just syntax of a while. In the same fashion, we can actually have a for syntax, something like this. For, again, it has initialization. So some int I equal to 1 and I less than or equal to 10, I plus plus. And here you can actually have whatever the statement that you want to write as part of the body of the loop. So I just want to print the I value here. You can do that. So if you observe the while and for, so while we have initialization is some part at some position, and update statement in some position that is within the body of the loop, and you have that condition or the expression written as part of the while. So these three things are mentioned in three parts in while, but in for loop you can actually have all the things mentioned in a single line. So that's why this for is considered to be advanced loop. Okay, so now here, so we have so many loops. Why so many loops? While is there, and whatever you write with while can be written with the for loop also. But for is considered as advanced because you can actually have all that initialization, test condition, update statements in a single line. Whereas in while you require a three separate parts to mention them. So do while is also similar to uh, while only. Only thing is this is exit control. This is exit control. And here while is entry control. What do you mean by entry control or exit control? Entry control means the condition is checked first and then you enter into the body of the loop. Whereas in the do while, the condition is checked at the end. So directly we will enter into the loop body, and later we will check the condition. So that means your loop body is going to get executed at least once actually. And coming to for each, so whenever we have a group or whenever we have a collection, right? Of course, we have group as an array and we have collection framework in Java. We can always use for each whenever you are working with these groups or collections. The syntax will be so easy, and syntax will be something like this. So I'm not writing the program, but I'm telling you. So it will be something like this: for each item, okay, each item in particular group. So you have to mention what is the group name, and then you can actually access that particular item. So you can actually print that item also. That's simple. So there is no initialization, no test condition, no update statement, right? You have to mention here what is the type of that item and what is the group name. That's it. That simple is that. Okay, so these looping statements will make the programming easy, and the program blocks, if at all you wish to run for n number of times, then you can put that block into any of these loops. That's how these control statements help improve our programming. And then coming to the last of the control statements, they are jump statements. Break, which actually comes in switch. So then we call this as a labeled break, and it can be used in loops also. Any loop can be broken. If certain condition is met, you can actually break that loop and you can come out. As an example, when you are searching some element in a group, whenever you found that, you can straight away come out of that searching because already you found it. Even after finding, you need not to continue in the loop. So break helps in that way. And continue is actually to skip certain loop iterations. Continue is to skip loop iterations. So loop will get iterated, and you don't want to execute the loop body for some time. So loop is executing, let's say 100 times, and in that you want to skip that loop body execution for, let's say, 10 times. You can do that. So that is with the help of continue statement, continue, continue. And yeah, so then comes the return statement. The return statement will actually make your program getting terminated. Okay, you can actually terminate the program directly by using return statement. Okay, so based on certain condition, I can actually say return, then I will come out of the program. My program will never get executed. I am stopping that. Okay, so my program is sequentially getting executed, and I will write a condition. If some condition is matched, then return. So you will come out of the program. Your program is going to get terminated based on the condition. That actually we can do. So these are all jump statement. All of them we will see with examples in very detail. This is just a briefing of what are control statements and what is the purpose of this control statement, what are available as part of the basic programming constructs. Hope you have understood about the control statement. And in the coming sessions, we will start one by one and we will learn them with proper programmatic examples. Thank you.